Hello, my friends. Welcome to a new video of Dr. Cat Code. In this video, I'm going to talk about neural networks for AI and machine learning. As you may have already noticed, in the recent years and especially in the recent months, AI has taken the world by storm. But have you ever wondered why? Why does it work? Why does AI work? Why can AI perform some of the tasks that you only can imagine the human intelligence can do, such as image and text and handwriting recognition, voice recognitions, object recognitions. In this video, I'm going to gently introduce the reason behind and how neural networks can perform intelligent tasks. If you think this type of video is useful for your learning, please make sure to like and subscribe to the channel to make it easier to see the future educational content from me. Okay, so let's talk about neural networks. Neural network is one of the main and common techniques in AI that are employed extensively recently in many different areas. So what is this thing? Neural network or artificial neural networks are inspired by the way that biological neurons in human brain signal to one another. So as you already noticed from the names, neural network is basically inspired from the way human brain works because we have neurons inside our brain. They sending signal from one to another, and it will help with transmitting the information as well as transforming the information and turn those information into answer or decision for some certain tasks. Neural networks are widely adopted in many machine learning and AI applications. For example, computer vision, object and face recognition, natural language processing (NLP), handwriting and voice recognition, finance and business, stock and house price prediction. Especially in the recent months, there's a rise in the popularity of generative AI for text and image and even video generation. So let's dive deep into the reason why and how neural networks can perform these tasks that we always think can be done by the human intelligence. So neural networks have multiple components, but they normally have three main components. One is the input layer, and another one is the output layer, and some 0, 1, or many hidden layers in between. So when we have multiple hidden layers, we call this deep learning. So deep learning is just a subset of neural networks where we have multiple hidden layers. So let's look at this example to see how neural networks can see images and identify the object in it. So if you look at the pictures of the cats and dogs that I have over here for the input layer, you can see that each of the images is comprising multiple image pixels. Each of the pixels carry a value as identifying the colors and of that pixels. So when you have, say, for example, an image of 256 pixel width and 256 pixel wide. So the total number of the pixels on this image will be 256 times 256. So there are plenty of pixels. So these pixels can be used as an input layer. And when these pixels go into the input layers, you can see the connection here from one layer to another layers. So this connection here carrying the ways that has been trained for the neural networks to be able to convert the pixel into more prominent and meaningful things. For example, areas, lines, curves. So with those information, we can go into further layers when we can have more meaningful understanding of those curves, lines, and areas, colors. And from there, we can form some more information to make the decision on whether the input pictures has a dot or has a cut in the output layer. So the same idea can be applied for a lot of other tasks that neural networks can do. For example, handwriting recognition. Like you're writing a letter A, or you're writing a letter of number 9. So those things have some certain features in it. For example, number 9 has one little circle and one line where there's a little bit of curve at the bottom. And because of those features, the neural network over the layers, one layer after another layers, can extract those information more in details. So one, it has a small detail. For example, the input image has one circle and one straight line next to that circle. It's very likely to be letter A, for example. Then you can say there's a 80% chance that it is letter A, and some percent chance that it's just 0 and 1, for example, like that. So that's how neural networks see things and can hear things. But how does it work? Like, how can this model can convert those images, text, sound into some certain classification that are useful? So in this video, in the rest of this video, and in the next video, I will dive deep into the reason why and how does it work. If you think this type of content is useful for your learning, please make sure to like the video and subscribe to the channel to make it easier for you to see the next educational content from me. Thank you. Okay, so to be able to understand how the neural network runs, we need to understand how one neural network unit works. So for a neural network unit, we can call it perceptron. In this particular symbol model of a neural network, we only have one output and 2 inputs. So as you can see over here, we have 2 inputs, x1 and x2, and we have 2 parameters here called w1 and w2. W1 and W2 are the parameters of this perception model. So we call this weights. And there's another parameter is called bias. This allows us to introduce some sort of prerequisite information into the model, some sort of bias. And all these inputs and bias are going to a node called summation function. This summation function essentially is just a function. it's just a sum function of the multiplication of the input and the corresponding ways. We have x, in this case, we have two inputs, right? So if you look at it over here, the summation function x equal to x1 times w1 plus x2 times w2 plus b. B is the bias. Okay, so once you have calculated the sum of the input and the inputs and the bias, you can let it go through an activation function. There are many different activation functions, and probably I will need to make another video on the pros and cons of each of the activation function. But for the purpose of this introductory video, I'm going to use a very classic and very popular and very practical activation function called sigmoid function. There are many reasons why sigmoid function is very suitable for neural network. But one of the key things that I can tell you right now is no matter what input this function takes, it always returns a number between 0 and 1. So it can squash a wide range of input from minus infinity to plus infinity into the range of 0 and 1, make it very easy for you to interpret the output. Okay, so that is the structure of a neural network unit, a symbol illustration of a perception. So let's see how it works. Let's assume that I have already trained a perception model. As you already know from my previous slide, I already told you that the model itself actually have some parameters, and the parameter dictate how the models behave. We have the bias, which is 1, 2, 3. I assume that this model has been trained, so the train value here is 1, 2, and 3. And another two parameters for the model is weighs 1, W1 equals to 0.6, and W2 equal to minus 0.9. So what does this perceptron model example, what does this example of a perceptron model do? This model take into the price and the distance to work of the house, and it will calculate the house quality. Okay, so say for example, if the price is high and the distance to work is small, then the house quality is high, and vice versa. If the price is low and the distance to work is far, then the house quality is low. Even though this is just a toy example, the way I choose the parameter for W1 and W2 have some meaning to it. For example, in this case, the W2 has negative value and it's quite close to minus 1. It means the distance to work is very important. And the larger the distance to work, the lower the house quality would be. So I can, as you can see here, that's why I put a negative here. And the price is 0.6 because, you know, if the price is high, definitely the house quality gonna be higher. But if it's too high, then it may not be feasible or possible to buy the house. So I put 0.6. So let's see how does this model perform on any sort of input and what sort of calculation or output that it will give the user. So in this example over here, I choose x1 equal to 500 and x2 equal to 10. It means price is 500 and distance is 10. So the price is quite high and the distance is quite small. I calculate x as 414, and from there I can calculate y as 1. So it means it's the upper, it's nearly 1, right? Approximate value. It means if the price is decently high and the distance to work is low, then you have high house quality, right? So that's the beauty of the sigmoid function as well. From this random 414 number, we squash it into a more meaningful and more and easier to interpret a number in the range of 0 and 1. I tried with another example here. When I put x1 equal to 10, the price is low, x2 equal to 1000, the distance to work is high. Then you can see that y now is approaching 0 and the value is nearly 0. It means when the distance to work is far and the house price is low, then probably the house quality is low as well for this simple example model. So now you understand how a trend perception model works. It's going to be very similar for a full neural network with multiple perceptrons or even multiple layers. But how can I come up with these numbers for the model? How can I train the model? Okay, to train a perceptron model, we need to answer a few questions. How does a neural network learn? What is training data? What is forward propagation? What is back propagation? What is gradient descent? I have no idea about multivariable calculus. What about mathematics behind this? So in my videos, I will answer these concerns, these questions that you may have when you are questioning how to train a neural network, or in this particular case, how to train a perceptron model. You can see all these answers in part 2 of the video at my YouTube channel, Cat Can Code. Make sure to like this video and subscribe so that I make it easier for you to see the next videos and other educational content from me. Don't be discouraged with all the mathematics that are required to understand the training process of a neural network. I will gently walk you through all of these points slowly and carefully so that you will fully understand, so that you can apply neural network in your application. You will feel more confident to use a neural network applications. Also, you can make some modifications so that you can improve it and use it in some more sophisticated real-world application as well. Okay, thank you very much for watching. Don't forget to like and subscribe to the channel to see the next videos more easily. Thank you for being part of the Cat Can Code community. I really appreciate your support and take care. See you in the next video. Goodbye.